Hello guys, welcome back to Math Zone African Motives. We are still working on our revisions for mathematics grade 10. So this is a typical exam question that we are going to actually work with for the March 2023 exams, which is from the KZN province. So guys, we do not need to waste much time, simply gonna quickly rush through our questions. So make sure that you read your instructions and information that you are given, especially here if necessary. Round off answers correct to 2 decimal places unless stated otherwise. So also make sure the workings is done properly, guys. All right. So this is it. On question number 1, you were given on 1.1 if x is an element of values. These are the values that represents x. For each value of x that you're given, we are being asked to choose the value of x. Choose from these values, all right? From the given set that will make the expression of this expression, okay, be what? This expression is supposed to be rational. It can be undefined. It can be irrational. It can be non-real. So this is it. We are simply going to substitute, guys. We know our definitions. If we are having a rational number, remember this one, we are supposed to write it in the form of a over b, where a and b are integers. All right. In that case, a and b must be what? Must be integers. Must be integers. So in that case, if you are referring a and b, they must be integers. And in that case, b cannot be equal to 0, remember? And undefined, if a number is referred to as undefined, that is something that we cannot actually simplify, which is numbers that are being divided by 0. So if we have got a number, a over 0, is it b over 0, whatever that you have, once you divide that number by 0, it's undefined. Then irrational is the opposite of what we have here. We cannot express it in that form. It is actually impossible for us to have it in this form, all right, or in this format. These are numbers such as numbers that are under the square root, such as square root of 5. We cannot simplify such numbers. Those are irrational numbers, okay? So rational, they can be expressed in the form of a over b, whereby we talk of the whole numbers, we talk of the proper fractions, we talk of the mixed fractions, all that. The non-real, that is actually mathematically, we cannot simplify that in terms of, remember, the real numbers. We can evaluate those numbers. They are on a number line. Is it a whole number that we are talking about? 1, 2, 3, are they decimals? 2,5, whatever that you have, guys, even the square root of 3, as long it can be simplified even on a calculator, that part is part of what? The real. So what is not real, non-real, cannot be evaluated. Such numbers will be carrying negative, such as square root of negative values. You cannot simplify such, all right? So these numbers are non-real. So e.g. square root of what? Negative values, square root of -7, whatever that you have. So if you understand this, guys, it was going to be easier for you because you simply have to substitute these values, all right? You just need to understand your ways, guys. In that case, you just need to substitute when x is -2. Let's substitute in the given part of our expression, that part that is under the square root. Under the square root, it's 18 over what? So we want to simplify the part that is under the square root. Is the square root of 18 over 4 minus x. So let's substitute when x is -2. All right? When x is what? -2. When x is -2, we are going to have the square root of 18 over what? 4 minus, in place of x. Our x is what? Our x is -2. So take note the value of x that we are given there is -2. So it will be minus, which is a plus. And simplifying this, we just need the numbers, the number that is under the square root there. All right. The number that is just under the square root is the one that we need. All right. So I'm just going to use my calculator here. So that is, I just need the part under the square root. Take note, it's a fraction. So that's 18 over what? 4 minus and minus is now a plus. So that's 4 plus 2, which is 3. So it simply means we are going to have the square root of 3 there. It is going to remain as the square root of 3. And can we simplify the square root of 3? Is it direct the square root of 3? Check here. We cannot simplify it. As a decimal 1,73, that is endless decimal. A non-recurring decimal does not even end. Does not end. That is when x is what? When x is 2. When x is -2. So when x is -2, what type of a number do we have there? Square root of 3. What type of a number between these? Yes, the calculator can simplify it, but us, we cannot simplify the square root of 3. It cannot be expressed in this form. It is not here. It is not square root of a negative. It lies under here. The irrational number, such as the square root of what? Such as the square root of 5. So for the irrational number, our x must be what? Our x must be -2. In actual sense, we're supposed to fill up everything and finish up. All right, let's just move on to 2. When x is 2 here, all right, that is the square root of 18 over, all right, this is 4 minus x. So that's 4 minus our x is what? Our x is 2, like this. All right, so let's see on our calculator. Sorry for that. So our calculator here is going to be a fraction, 18 over what? Sorry for that. That's 18 over 4 minus 2, like this, which is what? Which is 9. So it is going to be the square root of 9. And the square root of 9 can be simplified. We know this, guys. The square root of 9 is what? Is 3. So this can be simplified. And 3, that's a whole number. You can call it an integer. It's a whole number. It can be expressed in this form of a over b. 3 can be written as 3 over 1. That's a rational number. So you're talking of what? A rational number. When x is what? When x is 2, we have what? A rational number. Is it undefined? It can't be undefined when it is a rational number. It can't be an irrational number when it is a rational number. It can't be non-real. So that is it, guys. All right, let's move on to another one. When x is 4, you're going to substitute 4. When x is 4 in place of what? In place of x here. That is going to be the square root of 18 over what? 4 minus, remember our x is what? Our x is 4, like this. So let's just simplify the part under the square root. All right, under the square root, there is 18 over what? 4 minus 4. So this cannot be mathematically mathematicalized because of this, the denominator there. All right, it is because of what? The denominator here, 4 minus 4. 4 minus 4 is what? It's 0. So it's like we've got 18 over 0. So remember I said when it is over 0 like that, once you have 18 over 0, a over 0, a number over 0, that's undefined. This one, it cannot be simplified. It's part of what? Undefined. So when x is 4, this part is what? Is undefined. All right, let's move on to the last part, which is when x is 5. You're going to substitute in place of x there. It's going to be a 5. So when x is 5, that will be the square root of 18 over 4 minus our x is 5. So just simplifying this on our calculator here, it's going to be like this. That's minus 18. So you're going to have the square root of minus 18. Can you simplify? the square root of minus 18. We can't simplify this, guys. Take note, square root of minus 18 cannot be simplified. It has a negative. So these ones are non-real. The numbers that has got a negative. So when we've got a negative under the square root, those are non-real values. So we have a non-real value when x is what? When x is 5. So take note here, they're saying, choose the value of x from the given set of that will make the expression. Choose what is the value of x. So for us to have a rational number, which is what? Which is this 3 here. Our x must be 2. So these are the values that we need. All right. So guys, revise your numbers. I did this part on the introduction, working with the number systems, working with numbers. So make sure that you go through the types of numbers, even check your grade 9. I also talked about that, about numbers. It can be easier because that is what they are simply talking about, even here on this type of equation. So what are we given on this type of equation? Between which two consecutive, all right? Which two consecutive what? Natural numbers. A natural number, we are talking about whole numbers, but 0 not included. That is the part of what? The natural numbers. 0 is not included. Not included. But these are what? These are integers. All numbers. The positive integers. Talking of positive integers there, but 0 is not included. So if we are talking about whole numbers, guys, what is the cube root of this? The cube root of what? The cube root of 40. 40. The number that we have there, which is 40, just like this, guys, 1.2. So the cube root of 40. 40, this number here is not a perfect cube because technically the number there is 3 inside. If you are given the square root, let's say they say square root of 40, you must work with the perfect squares. I talked about this. If you are given the cube root like this, what you are having here is the cube root. So there you must work with what? Perfect cubes. Perfect cubes. What do we refer as perfect cubes? These are the numbers such as 1 to the exponent of 3, it gives us 1. 2 to the exponent of 3, it's 8. You can simply use your calculator, guys. 3 to the exponent of 3 is 27. These are the perfect cubes. 4 to the exponent of 3, which is 64, and so on and so on. So these are the perfect cubes. 5 to the exponent. So you can simply use your calculator to find or to just know these. To the exponent of 3, because of what? The number here is the cube root. So you must work with what? Perfect cubes, these ones. These are your perfect cubes. So you just ask yourself, this number 40 here is between which numbers of these perfect cubes that you have here? 40 here, this 40 is between which numbers? Is it between 1 and 8? Is it between 8 and 27? Is it between 27 and 64? Is it between 64 and 125? Between, we are saying, just like we've got 1 and 3, we are saying 2 here. 2 is between 1 and 3. We cannot say there's a 3 and 4 like this. Then we say 2 is between 3 and 4. Or maybe, let's just say there's a 5 like this. Between 3 and 5, we cannot say 2 is here. It's impossible. But between 3 and 5, there's what? There's a 4. So this is between, in between. That is what I'm simply asking you guys to say. So which one here, 40 here, which part is it going to lie? Is it here? Is it here or is it here? So it's going to be in between here. 27 and what? 64. 40. It's in between these numbers. 27 and 64. These are your boundaries. These ones, 27 and 64. So what does it mean if I'm saying these are the boundaries? It simply means the cube root of 40 must be greater than the smaller value, which is the cube root of what? Of 27. This is our smaller value. Remember, it's in between 40. It's in between these two numbers. So it must be greater than the smaller value, but less than the bigger value, this 64. But it must be what? Cube root of 64. Remember, we are using what? The cube root. If it was a square root, I said you must what? Work with perfect squares. 1 squared, it's 1. 2 squared, it's 4. 3 squared, it's 9. The perfect squares are the ones that you work with. But here, you're going to work with what? The cube roots, just like that. Just like that. So these numbers, we can determine them, guys. We know the cube root of what? 27. What is the cube root of 27? It is 3. All right. So we are simply saying, all right, let me write this properly. The cube root of 40 must be what? Must be greater than what? What is the cube root of 27? This is 3. But less than the cube root of what? Of 64, which is 4. So it is in between these two natural numbers as we are given here, the natural numbers. So that is the case. So meaning to say the cube root of 40 lies between what? It lies between 3 and what? 3 and 4. So this is our case. It lies between these two. So guys, just 2 marks. Guys, you just need to revise your basics there. It's not that much. 1.3, factorize the following expressions fully. All right, 1.3. We are given x to the exponent of 4 minus 16. So guys, if you understand your exponents, you'll see that this is part of a difference of 2 squares. Why part of exponents? X to the exponent of 4 is the same as x to the exponent of 2 raised to the exponent of 2. This 16 that we are seeing here is the same as 4 to the exponent of 2. So if you understand your exponents, guys, you see that this is a difference of 2 squares. Why? Remember, a squared minus b squared is equal to what? A minus b into a plus b. A squared minus b squared. If these numbers are being raised to the exponent of what? 2, a and b. Being raised to the exponent of what? To the exponent of 2. That is the major part. Here, a, b, the first bracket is going to take that a and b, subtracting another one, adding. So the order here does not matter. The order here does not matter. So guys, understanding these guys it's important, because you know that here, if I want to write it in this form of a number raised to the exponent of 2, it's going to be this to the exponent of what? 2. So it can be written as x squared to the exponent of 2 minus 16 can be written as what? 4 to the exponent of 2. You're done. So this is your a, this one. It represents your a, this one. It represents your what? Your b. Understanding these guys is important. This is your difference of 2 squared. So if it is a squared minus b squared and it gives you a minus b, what are we going to have? A minus b. So it's x squared minus 4. A minus b into what? A plus b. A plus b. So this is your a, this one. This is your a, this is your b. So another bracket, it's a plus b. So it's x squared plus our b is what? It's 4. This is where you are. So check again, because there can be a possibility of a difference of 2 squares again. And in this case, if you have to check properly, we have a difference of 2 squares again. X squared minus 4. 4. This 4 here is same as what? 2 squared. So we are back to the difference of 2 squares. A squared minus b squared. A squared minus b squared. A minus b, a plus b. So we've got x squared, 2 squared, A difference of 2 squares again. This number here and this 2. 4 here is same as 2 squared. So meaning to say we've got what? X minus 2, A minus B. So that's X minus 2 into A plus B, that's X plus 2. The square root of X squared, which is X, the square root of 4, which is 2. One subtracts, another one adds. What about this one? Can we factorize this? No, it's impossible. So you just have to rewrite as it is. X squared plus what? Plus 4. There is no sum of 2 squares. We only have a sum of what? 2 cubes. This one can be factorized, not sum of 2 squares. For 2 squares, it's impossible, but for a difference of 2 squares, it's possible for you to factorize. So guys, as long as it can be written like this, difference of 2 squares. That's the difference of 2 squares. You're done. So please revise your basics of your difference of 2 squares because they can give you different expressions. 1.32, we are given that was 6z squared y minus 10zy like this plus 15z minus 25. So from what we are given, once you're given 4 terms as you are working with your factorization, count the number of terms. 1, 2, 3, 4. As long you are working with the quadrinomials, what are we going to do? We factorize by grouping. The question here is on the factorization, remember. We factorize by what? By grouping in this case. So by grouping, you're supposed to check between the first 2 terms if there is anything common, which is the highest common factor. And also for the last 2 terms is if there is anything common. So looking into the first 2 terms, we can see that there is something common between 6 and 10 there. 2 is common, the z squared and zy is also common, all right? On these last 2, we can see the 5 is common between 15 and 25. 5 is common. So meaning to say, we can group them as they are. We can group them as they are into 2 as they are because we've got something common here and also common here. So you're asking yourself, for the first 2 terms, what is common? What is your highest common factor? You factor out the highest common factor between these 2 terms. So 6 and 10, 2 is the highest common factor, remember? 6 is 2 times 3. 10 is 2 times what? 2 times 5. So 2 is common. That is the highest common factor. Z squared and Z, gonna take Z, the one with the smallest exponent. Y and Y, we're just gonna take that Y as just the same part, guys, all right? So this is it. Let's factor out. Remember, factoring out, you're gonna divide. So this is it to this one. Divide there. What are you going to have? 6z squared y over 2zy like this. That will be 3 z y and y is gonna cancel. So that's 3z. Okay. The same part minus 10z divides to this one. What are you going to have? Minus 10zy like this over 2zy. So the 2 and this is going to be negative 5. Z and Z cancels. Y and Y cancels. So you remain with what? Negative 5. Just like that. So that's 3Z minus 5. So for the last 2 brackets, you must check what is common. And whatever that you're going to factor out here must give us the same bracket as this. So what are you going to factor out? Between 15 and 25. That's 5. Remember, 15, guys, is 3 times what? 3 times 5. 25 is what? 5 times 5. So 5 is the highest common factor. But is it going to be a positive 5 or is it going to be a minus 5 so that we have the same bracket as this? So our Z here is positive. So to have a z which is positive, we must factor out a positive because we already have a positive here. So we're going to factor out positive what? 5. Remember, I said 5 is the highest common factor here. So factoring out positive 5, 15z divided by 5, guys, is going to give us what? That's 3z, 15z over 5. 5 into 15, that's 3. So it's going to be 3z minus 25 divided by 5 is going to be what? Negative 5. So as we can see clearly, the two brackets are the same. They're the same. This bracket here and this bracket here are the same. So we can factor out that common bracket, which is the same. This one and this one. It's common. So you factor it out. 3z minus 5. By factoring out this bracket, what are you remaining with here? You take it as it is, 2zy. What are you remaining with here? You take it as it is, plus what? Plus 5 in another bracket. You're done. Is there anything common? Nothing. In this bracket, is there anything common that you can factor out? Nothing. In this bracket, is there anything common that you can factor out? Nothing. So we have factorized fully. We are supposed to do our factorization fully or completely. That is the case. Just like that. All right. So that is it, guys. Let's see another question. Simplify the following expressions fully. So this one, guys, is just expansion of what? Expansion of brackets. So on 1.41, we are given m minus 4n into the bracket of m squared plus 4mn plus 16n squared, like this. Remember, expansion of brackets. There are two brackets, so we can take the first bracket here to expand everything in the second bracket. All right. So we're going to take this one with two terms where we have got a binomial to expand this trinomial in the other bracket. All right. So here, m expands or multiplies everything. The minus 4n does the same, multiplies everything. All right. So let's start with m. So it's going to be m times m. That is to the exponent of 3. M to the exponent of 3. All right. Your laws of exponents, guys. M times m squared, you simply add the exponents, all right? Then m times 4mn. So it's 4mn like this. So this m and this m will give us m squared. So that's plus, all right, 4m squared n. Remember, there's n there, okay? The same thing, the m multiplies the 16 there, which is at the end, and it's positive. So that's positive 16 m n squared. Take note, it's m and n squared. And also on the order there, take note here, you started with m followed by n. Do the same thing, m followed by n. Do not mix up to say, this is m and this is n. Other part, you write this as 16 n squared m. It's one and the same, but you get confused mixing the same thing. Just if you start with m, follow the same thing. Start with m followed by what? By n. All right. I think this part case is clear. That is it about the 4. We are done with the 4. I mean the m, this one. So let's move on to the minus 4n. Take note the sign. There's a negative there. So that's negative 4n times what? Times m. Negative 4m, negative 4n times m. So that's negative 4m squared and n. So remember the order. So we're going to start with m squared followed by what? By n. Okay. Minus 4n multiplied to this 4. So that's minus and a plus. That's a minus, right? Take note, minus and a plus, that's a minus. Then 4 times 4 is 16. We're going to have m, n and n, that's n squared. So make sure you start by the sign You move on to the numbers, the variables, the sign minus there, and a plus, it's a minus. The numbers 4 times 4, 16. Then m is just there's the only m there. Then n and n is going to be n squared, okay? You move on to the other part that is minus 4n. It multiplies the last term there. So take note the sign minus to a plus. That's a minus. Then the numbers 4 times 16, that's 64. Then n and n squared, just like m and m squared, it gave us what? To the exponent of 3. So it will give us to the exponent of 3. So this one is n and n squared. So that's to the exponent of 3. So that's it. At this stage, you're supposed to collect your like terms. Simplify. Collect what? Like terms. So remember the like terms, it must be the same variable, same exponent. Same variable, same exponent. Do we have any part where we've got m squared? We do not have. Do we have any part where we've got m squared n, m squared n, m squared n here, m squared n? So it's there. So we can even simplify that part here. 4m squared minus 4 m squared n, this one. 4m squared n minus 4 minus 4, that's what? That's a 0. So this one will cancel. This part, guys, was gonna what? Was gonna cancel. The same with this one. 16m squared n minus 16m squared n. This part also was gonna cancel. So you remain with what? M cubed here. You remain with what? Negative 64 n cubed, just like that. So if you know the identities of algebra, they are algebraic identities. Remember, expansion of brackets, factorization of these. A cubed, the sum and difference of what? Of 2 cubes. If you properly see, you see that that's a sum and that's a difference of 2 cubes there. Which is this part here that we see here. So understanding that, you do not waste your time in exam, because you see, okay, this is from our difference of 2 cubes. Okay, let me explain this way, guys, that I'm trying to explain here. Take note, is 2 marks there. So you can even, let's say you understand your difference of 2 cubes, right? Like this one, you understand that a cubed minus b cubed is equal to what? A minus b into a squared plus ab plus what? B squared, like this. This is what you understand. If you understand this, guys, you're simply going to check to say, okay, there is m minus 4n. Then I've got m squared 60. Guys, just look here. A, this is a squared. This is m squared. This is 4n. 16n. If you square it like this, if you square it, it gives you 16n squared. This b here, this is the b squared. Exactly the same format. What about this part of ab? Is it the same format? If you multiply our a, which is m, and this one, which is what? Take note, the negative, don't count the negative. Take the numbers there, the terms m and what? M and what? 4n. Multiply them. You get 4mn. Exactly this part here, 4mn. So meaning to say this was exactly an expansion from what? From a minus b. From a cubed minus b cubed. So if you understand this, guys, you simply, okay, my a according to my question here, it's what? It's m. So if it was taken from a cubed, it means our a, and this is our b. So it's going to be m cubed minus b cubed, which is 4m cubed. The whole of this part here is equal to this, which is equal to what? M cubed minus 4 to the exponent of 3, which is 64. m to the exponent of what? M to the exponent of 3. Is it m? This is n, guys, all right? This is n. So that's n to the exponent of 3. Exactly the same answer that we got by expanding. But you can just find this by analyzing. You know, guys, your expansion, I talked about this as a separate class actually of the sum and difference of two cubes. So just go through that part. It saves you time in exam, knowing that. But if you do not know, guys, just expand the same way that I did on the first part. You can see that you still have the same answers. You still have the same answers, 2 marks. The same part on 1.42. This expansion here, 1.42, you've got 2 ways, 2x minus 3 over 2 squared. What does it mean? It means you've got 2 brackets. So if you do not understand the use of identities, guys, here, if you do not understand the use of identities of algebra, in algebra, you've got identities. If you do not understand that, it means you've got 2 brackets like this from your understanding. Therefore, what are you going to do? You're going to expand just like the previous case. One bracket expands what? Expand the other from your FOIL method. So you're going to expand. The 2x multiplies what? The 2x. So it's 2x times 2x. 2 times 2, which is 4. X times x, which is what? X squared. Then we move on. The 2x multiplies the minus 3x. So it's like this. 2x times minus 3 over x. This is minus 3 over x. Remember, guys, in algebra, if you're given a term, it is same as over 1 as a fraction. So the x and the x was going to cancel. Then we've got 2 times what? 2 times negative 3, which is what? Negative 6. 2 times negative 3. All right. So that is the case. You're done. You move on. You're done with the 2x. You move on to the minus 3 over x. Minus 3 over x, it multiplies what? 2x. So it's the same thing, guys, just like the previous case. Minus 3 over x, it multiplies what? The 2x. So it multiplies the 2x like this. 2x is the same as 2x over 1. So this x and this x cancels. So it's minus 3 times 2, which is what? Which is minus 6 again, just like the previous case. Then you move on to the last part, the minus 3 over x times the minus 3 over x. So it's negative to negative. That's what? A positive there. Negative times negative. That's what? That's a positive. Then we multiply 3 over x times 3 over x, guys. It's 3 over x times 3 over x like this. 3 times 3. Remember, numerator to the numerator. 3 times 3, which is 9 over x times x, which is x squared. So it will be 9 over x squared like this. Just like that. Collecting your like terms. In this case here, we've got what? Like terms. So you must simplify the like terms. Meaning to say at the end, it is going to be 4x squared minus 6 minus 6. That's what? Minus 12 plus 9 over x squared. These are not like terms. These are not like terms, guys. This is x squared. 9 over x squared, remember, it's same as 9x to the exponent of minus 2. They are different. This is x squared. This is x to the exponent of minus 2. So they cannot be added or they cannot be simplified, this part. So in this case, we are done like this. So like I said, it is a condition where you do not actually understand your algebraic identities, because if you understand your algebraic identities, you know that a minus b squared is equal to what? A squared minus 2ab plus b squared. The first minus the last. First squared minus 2 times the first times the last plus the last squared. So in our case, this is our first 2x. And this is our last, the 3 over x like this one. This is our last. Just like this is our A, this is our B. So if truly we understand this, we know that if anything is written like this, raised to the exponent of 2 as we see it here, it is going to give us what? A squared. Our A is what? 2x. So that's 2x squared. A squared, yeah, A squared. So it's 2x squared. What represents A? So that's 2 squared, which is 4, x raised to the exponent of 2, which is what? 4x squared. So that's 4x squared. You move on to the other part, which is what? Minus 2ab. Minus 2ab. What does it mean? Minus 2 times A. Our A is what? Our A is 2x. Times B. Our B is what? Our B is this one, 3 over x. Don't take the minus. The minus is already involved in the formula. The B is the number, this one, 3 over x. So that's 3 over what? X. You multiply. Remember algebra, guys. This is same as 1 over 1. So the x and the x can cancel. You multiply minus 2 times minus 2. That's minus 4 times 3, which is what? Minus 12. So that will be minus 12 there. There's no x. X is cancelled. So if what? Minus 12. Then you move on to the last one. Last term squared plus last squared. So that's plus b squared. Plus b squared. What is our b? Our b is 3 over x. So that's 3 over x. But they are saying what? Squared. 3 squared. It's what? It's 9. X what? X squared. Just like that. So that will be 9 over x squared. Remember, you're allowed to expand this. Every term is raised to the exponent of what? Of 2. So we're seeing knowing these algebraic identities is important. We still have the same answer, just like the previous case. Exactly what we got. Just like that. All right. Let's see another part. 1.43 we are given. To simplify again, this is on the simplification. So if we are to consider here, we can see that we just needed to factorize the x squared minus 4x over x cubed minus 1 minus 1 over x minus 1 like this minus 2 over x squared plus x plus 1 like this. So you just needed to factorize. Remember your factorization, guys. Factorization. X squared minus 4x. They were just given 2 terms, binomial. Just look for the highest common factor there, which is what? Which is x. So you can divide x squared divided by x, that's x. Minus 4 divided by x, that's a minus 4. You're done. All right, there we've got x cubed minus 1. Which part are we going to use? This is the part that we've been talking about here. When we expanded here, remember you got something of that nature, a cubed minus b cubed, the difference of 2 cubes. This is exactly what we have here. That's a difference of 2 cubes. X cubed minus 1. 1 is same as 1 cubed. Remember, 1 cubed is 1. So we have, guys, there a difference of 2 cubes there, where this part represents our A and this our B. So if truly you were having this A cubed, this one, as A cubed minus B cubed, or maybe you write it in form of X cubed minus Y cubed, guys, whatever part that you understand. If it was going to give you A minus B into A squared plus AB plus B squared, like that. Or you can write it in terms of Y then, which means it will be X minus Y plus X squared plus XY plus Y squared. If truly something of this nature can be written like this, it means we can write this one in that same format, because this is exactly what we have. X to the exponent of 3. 1 to the exponent of 3. So that's our A and our B. So it's supposed to give us what? A minus B. A minus B. A minus B, which is what? X minus what? X minus 1. Into what? A squared. Our A, the first squared. So A is X. So that's X squared. Plus AB. AB. A times B. So that's X times 1. X times 1 is what? It's X. And that's a plus. So that's plus X plus B squared. The last B with this one. So it's 1 squared, which is what? Which is 1. So it's plus 1. So this is it, guys. This is what you're going to have. So we are going to take this bracket in place of x cubed minus 1. These are the two brackets that you're going to write. X minus 1 into that. All right, so that's it, guys. So we got x minus 1 into x squared plus x plus 1, just like that. Minus 1 over x minus 1 minus this one here. As we can see properly, guys, here we can see that this x squared plus x plus 1 and this one is the same. Writing it like this here, leaving it like this, it means it cannot be factorized. This part here, whatever that you have, don't waste time to factorize this one here. This part of the quadratic that you have inside here. Never waste your time in exam. Whatever type of equation that you have, it cannot be factorized. So it also means this part here that we see here, x squared plus x plus 1 cannot be factorized. Never waste your time. So it is the same thing that we are seeing here. So this one cannot be factorized. You just rewrite as it is. 2 over x squared plus x plus 1. If you want, guys, just try. You'll see that. So this is it. We managed to factorize what we can. So according to addition, subtraction of fractions, guys, we know that we work with the LCM or the LCD of the fractions of the given denominators. The LCM, x minus 1. We have got x minus 1 there. So we're going to take it just appearing once here. Here it's appearing once. X squared plus 1. X squared plus x plus 1. This is the same. We are also going to take it as it is. All right, so let's divide. This into this. It cancels. This one, as it is here, it cancels. So meaning to say you're going to get what? A 1. So that's 1 times the numerator. 1 times the numerator as it is. Minus, you divide this one to this one. As you can see, the x minus 1 and the x minus 1 was going to cancel. You remain with this as it cancels. So it was going to be what? Minus 1 in the numerator into what is remaining when you cancel these two here. Do not cancel like this one to say it's no longer there. Just know that it will cancel like that, but just rewrite as it is, all right? So that's the case. The same part here, you divide your LCM to this denominator. The x squared plus 1 and this one was going to cancel, meaning to say you remain with what? You remain with x minus 1. This one and this one was going to cancel because it's the same. So it was going to be minus 2 into the numerator there, into what? What is remaining, because these two, they canceled. So you remain with what? X minus 1, just like that. From there, expand brackets and simplify. So expand brackets and what? And simplify. Each and every part that you are given, the first bracket, x minus 4, you expand by x, this one of x squared plus 1, x squared plus x plus 1, this one of x minus 4. So the first bracket, guys, do not even waste your time there, because we can see, guys, this is what? 1x. 1x, guys, is just like we've got what? We've got x there. 1x. So it's x times what? X squared. X times minus 4, minus 4x. You distribute that. Minus 1 multiplies everything. That's why you have to open the bracket, guys. Never take that negative 1 for granted. Once you see a negative, open the bracket. It means everything will be affected. Negative times x squared, which is negative x squared, negative times x, negative times 1, which is negative 1. You move on to this bracket. What is outside is what? Negative 2. Negative 2 times x, negative 2x. Negative 2 times 1 times negative 1. It's positive 2. Negative 2 times negative 1. That's a positive. Everything over what? Our denominator, this LCM as it is, which is x minus 1 into what? X squared plus x plus 1. Never expand your denominators, just leave them as they are. So you managed to expand. Now let's simplify by collecting the like terms. So by collecting the like terms in the numerator, we've got the x squared here and minus x squared. It was actually going to cancel. Let's move on to the part of x. All right, to the part of x, let's see what we have. There is a minus 4x here. There is minus x. There is minus 2. All right, let me just indicate the remaining ones, this one, once and for all, so that we just simplify. So let's see. This is minus 1 here. So it's going to be what? Minus 4, minus 1, minus 2. Use your calculator, guys. It was going to be minus 7. So that's minus 7x. Minus 1 plus 2, that's positive 1. Everything over what? That's x minus 1 into x squared plus x plus 1, like this. So remember, guys, we are done here. Actually, we're done. But remember, if you are given like minus a plus b, you can just write as b minus a, starting with what? Positive. So here we can even start with this one, a positive number. You can just write as 1 minus 7x. Just one and the same. We are just starting with a positive. Not to say this one is wrong. No, it's fine as it is. But you can just even write it this way. It does not even affect your final presentation. Like here, the denominator is not even affected. It's just rearranging. You can even leave it like that. So this is in simplest form. Nothing is common that can be simplified. We do not have anything that is common that we can simplify further. So make sure that when you are given algebraic expressions, factorization, where it is possible, then you simplify further from there. All right, let's consider another part where we are given determine without the use of a calculator. All right, so this is how many marks? 2 marks. All right, just direct here. So that is 1.5. You're given 2. This is 2023. And this is 2022 to the exponent of 2 minus 1. So when you're given such type of expressions, they just want to play around with you guys. Just try to figure out. Mostly try difference of 2 squares, because you can see here it's to the exponent of 2. And this is 1. Remember, 1 is a perfect square. It is also a perfect cube. 1 squared is 1. 1 to the exponent of 3 is 1. 1 can be raised to the exponent of any and remains as 1. So meaning to say, knowing this, guys, is going to help us to understand that this is a difference of 2 squares. Why? I can write this as 2023 over 2022 minus, okay, this is squared here, minus this 1. 1 is same as 1 squared. Same as 1 squared. 1 squared is 1. I haven't changed anything. But I'm just trying to figure out the difference of 2 squares concept, the one that I explained before, a squared minus b squared. It's a minus b into a plus what? Into a plus b. So understanding this is important, a and b. So this is our a and this is our b. So if you understand this, guys, you're done. Because you know that this is going to give us what? A minus b. So it was going to be like this. 20, 23 over what? So there we need, remember I say this is our A and this is our B. So the bracket of difference of two squares is A minus B, A plus B. So what is A minus B? A minus B, that's 20, 22 minus 1. That's A minus B. Into what? Into A plus B, which is 20, 22 plus what? Plus 1. So that's it. So understanding the difference of two squares is important because remember, guys, they said without the use of a calculator, so simplifying this 20, 22 to the exponent of 2 by head, guys, you're multiplying like this times. Guys, it's going to be a lot. But doing this, it is important because you'll notice something as you are simplifying that some of the terms here will be automatically be the same. Okay, let's simplify this. So it's going to be 20, 23 over what? Remember, brackets means like this. A into B like this is the same as what? AB, A times B, A times. So meaning to say we can even write as A times B, or you can even leave it like that, guys. But just know that it's a product here. It's your multiplying. So 2022 minus 1, we can subtract, removing 1 here. It's going to be what? 2021. 2022 minus 1. That's 2021 into what? 2022 plus 1 is what? Is 2023. We add 1 here. It's going to give us what? 2023. But remember the concept of the brackets, guys. It means you're multiplying these two. But there's no need for you to multiply this, expand this. Because we can see that this one and this one is the same. Remember, under a product, if you are given B over A times B, knowing that this is a product, you can cancel these two because they're the same. So you remain with 1 over A. So it's the same thing. 2023 can cancel. You remain with what? With 1. So that is simply going to give us what? 1 over 2021 times 1, which is what? 2021. Just like that. Knowing this part involvement of algebraic expressions, factorization, just like that. All right, so that was for 2 marks, guys, as you can see. Question 2, solve for x. Given this equation, that is 3 marks, and you are not even told to 2 decimal place and so on. So when you are not told, guys, to 2 decimal place and so on, you can simply use your factorization. 3x squared is equal to 5x plus what? Plus 12. Yes, you can use the quadratic formula. I'm not saying it's wrong. This is a quadratic equation. So remember the format of a quadratic equation: ax squared plus bx plus c is equal to 0. This is the format. One side must be equal to 0. So let's take these numbers to the other side of the equation. So it will be 3x squared. This one to the other side, it will be minus 5x. The 12 to the other side will be what? Minus 12. That's equal to 0. So guys, using factorization method, let's start by factorization. Then I'm going to use the quadratic formula because you are used to quadratic formula. I know that. Most of you guys, you do not want this factorization, but you can use factorization. Once you are not told, guys, to 2 decimal place or what, it means factorization is possible. Remember, factorization, you are going to need 2 brackets because you know this is, guys, the highest exponent is 2. It's a quadratic. So factorizing a quadratic expression, definitely I'm going to have what? 2 brackets. As long as it's a quadratic expression, you have what? 2 brackets. So working with a trinomial where we've got 3 terms like this, and the coefficient of x squared is not 1. Like what we have here, the coefficient of x squared is not 1. We can use the cheat method, guys, of factorize. You can, guys, there use any way that you understand on, if you are using factorization, on how to factorize. There are different ways. So I explained different ways, and I also explained this cheat method. So I'm gonna talk about that because it seems to be easier and you seems, guys, to understand it. So on our cheat method, you said We want to make the x squared 1. So you're going to take the 3 to the other side, to this part here, you multiply it here. So you remove the 3 by multiplying it here. So that's how we can cheat our question. So it will be x squared minus 5x minus 12 times 3 is minus 36. So this is what we simply do. Since now we have got the coefficient of x squared as 1, it enables us to put x here and put x here and factorize. Remember your factorization, guys, the coefficient, the constant. Factors of what? Negative 36. Factors, products of what? Negative 36, which you add and they'll give you what? A negative 5. Products of negative 36. There you think of 9 and a 4. But negative 36, it means this can be negative or this can be negative. But which part, when we add, we get what? Negative 5 when we add. If we add these two, yes, we're going to get a negative 5. If we add these two, guys, on our calculator, this was going to give us a positive 5. 9 plus minus 4. So we do not want this. We need where we get what? A negative 5. So that's negative 9 and what? Negative 9 and 4. So that's negative 9 here plus 4. Remember, this was a factorization from a cheat method where originally there was a 3 and we used a part where the 1 is. So we must bring back the 3. Wherever x is, I said you must bring the 3. Where x is, you put back the 3. You put back the 3. Then you factorize where possible in these brackets. Is there any part which is possible? Yes, the first bracket, 3 is common. So you factor it out. 3x divided by 3, that's x. Minus 9 divided by 3, that's minus 3. Into 3x plus 4. The other part here cannot be factorized. The number that you factored out here becomes useless. You do not use it. It becomes useless. Totally this one. You just take the brackets. Those are your answers that you need here. The brackets. These two, the brackets. X minus 3 and what? The 3x plus what? The 3x plus 4. The brackets. Those are the brackets that you wanted. So guys, like I said, for these brackets, it's in your hands. This one, guys, it's in your hands. Use whatever that you understand, any factorization that you have learned, but you're supposed to have these two brackets. Either you start with a positive to a negative, but you're going to have these two. So from there, either one of these two brackets must be what? Must be 0. So that's equal to 0, or this other bracket of 3x plus 4 must be equal to 0 from the 0 concept. So that's x is equal to 3. Or take this one to the other side, it will give us a negative 4. Then definitely you will have to divide by what? By 3. So x is minus 4 over 3. Or x is what? X is 3. This is from your factorization. But like I said, how to factorize this, it's in your hands. It's in your hands. All right. Using the quadratic formula, which seems to be the easiest method, and that's what you actually, guys, what you want. So you can also use that. So using the quadratic formula, so that's another way. Or using the what? The formula, quadratic formula. So using our quadratic formula, we understand that it states that x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a like this, where our equation is written in this format: ax squared plus bx plus c. Ax squared plus bx plus c. In that format, it means our a is what? The coefficient of x squared. So in this case, our a is 3. B is the coefficient of x. B, the coefficient of x, which is what? Negative 5. C is the constant, which is what? Constant, that's negative 12. So you're simply going to substitute into the formula. So that's minus b. Our b is what? Negative 5. Okay, plus or minus the square root of b squared, the minus 5 squared. So that's minus 5 squared minus 4 times a, which is 3, times c, which is what? Negative 12. So this is it, guys. Everything over 2a, which is 2 times our a is what? our A is 3. So from our quadratic formula, this is what you're going to have. Like I said, guys, on the simplification of our numbers, that at least show the examiner what is under the square root. What is under the square root? This part here under the square root, the numbers that are under the square root. So you can simplify that, all right? Minus and minus, that's a positive. Okay, plus or minus, it is going to be the square root of what? These numbers, only under the square root, this one, as it is. Just try to do that. Yes, you can use your calculator straightforward, the square root of this, you simplify everything that you have there. But let's just take the numbers only. That's minus 5 squared minus 4 times 3 times negative 12. Yeah, this one, negative 12. So that was going to give us 169. So under the square root, the number there is 169. Yes, we can simplify the square root of 169. No problem. 2 times 3 is 6. Knowing that we can simplify the square root of 169 or not, it is not important. Our calculator can do the rest. All right? Our calculator can do the rest, guys. All right? Did I show you guys? All right, I was supposed to. Sorry for that. Here. I wanted you to see this one. Here. Number under the square root only there. So it was going to give us 169. So from there, you can simplify starting with the positive on our calculator. All right. Just take this as it is 5 plus the square root of what? 169 like this over what? Over 6. So that was going to give us what? A positive 3. Or x is equal to, we move on to the negative. You just move on this, remove the plus, put a negative, that's negative 4 over 3. So that's negative 4 over 3. So these are the values of x that you're going to have. Same values just like the previous case. As you can see, quadratic formula can be used. Can use your quadratic formula. All right, looking into another question, that was 2.13, where we are given again to solve for x. So for x, 1 over 2 to the exponent of, this is to the exponent of x minus 1 is 128. So looking into our exponents, guys, 1 over 2. 1 over 2 is same as what? 2 to the exponent of negative 1. So you can write as 2 to the exponent of negative 1. But remember, there's an exponent which is already there, which is what? X minus 1. So this is equal to 128, right? But the question is, can we write this 128 in the base of what? In the base of 2. All right? Can we write it in the base of 2? So if you want, guys, to write it in the base of 2, like in its simplest form, remember 2 is the simplest form where we're talking about what? The prime numbers. So you can even check on your calculator, 2 to the exponent of 7. If you do not know that, you can use your calculator like this, all right? So you can simply check here. Let's hope I'm not going to miss my calculator here. So this is our calculator. So you write 128, the one that you want to check is equal to. Then for us to check the number, we're going to use shift. Then we press the fact. All right, where is my fact? If I'm using this calculator, guys, you see just was, yeah, the fact here, it's the B here. So it's shift, then fact here. So as you can see, it gives you the answer 2 to the exponent of what? 7 in the simplest form. So this is it, guys. The number 128 is equal to, then shift, you press this one, fact here, on this B here, on these commas here, 2 to the exponent of what? 7. So we can see that this is 2 to the exponent of 7. But guys, you were supposed to know this one, right? So this is it. When we are given this condition here, an exponent to an exponent x to the exponent of a to the exponent of b, remember, you multiply the exponents a times b. So this is the case. The minus 1 was going to multiply this part. So you can even just write like this, 2 to the exponent of minus 1. It multiplies x minus what? X minus 1. The minus 1 there is going to multiply everything. So you open the bracket for what? For x minus 1. It is equal to 2 to the exponent of 7. Yes, you can expand your brackets. It's fine at this stage, or you can even consider to say these bases are the same. There's a 2, there's a 2. So what are you going to do? We are going to equate the what? Exponents, because these two are the same. So this will be equal to this automatically. Minus 1 into x minus 1 is equal to what? 7. So solve for x. Expand your brackets by -1, divide, or you can even divide by -1 like this, by -1 if you want. Guys, it's mathematics, it's possible. Or you can expand the way that you are used to, guys. -1 times x, -1 times -1. That's what? +1 is equal to 7. So you take the 1 to the other side, or you subtract 1 both sides, or you take it to the other side. The moment it crosses the equal sign, it becomes what? A negative there. So minus x is equal to 7 minus 1, which is 6. Dividing by -1, both sides gives us the value of x, which is what? -6. Just like that. Just like that. So knowing laws of exponents is also important somehow. So this is it. 2.13. We are now given again to solve for x. This is 3 times x to the exponent of 5 over 4. All right. This is 5 over 4, which is equal to 96. This is a product. So let's start by getting rid of these 3, guys. It's just a product. So remove this by what? Dividing by it. Divide by 3 both sides. X to the exponent of 5 over 4 is equal to what? 96 divided by 3 is going to give us 32. So this is the case. When you are given these exponents, guys, like where you have got the rational exponents of this nature, you simply have to determine the reciprocal of the exponent or the inverse. 5 over 4, its reciprocal, you just interchange this. So you just interchange, it's 4 over what? 4 over 5. That's the reciprocal. So by multiplying by that reciprocal, or by raising this to the exponent of the reciprocal, which is 4 over 5, we are also supposed to do the same thing on this number, which is 32. We are supposed to raise it also to the exponent of what? The reciprocal, which is 4 over 5. Why doing this? Because we understand that a number times its reciprocal gives us what? A 1. So this number here times its reciprocal will give us a 1. That's x to the exponent of 1. That is the idea. So x to the exponent of 1 is equal to this. 32 to the exponent of what? 4 over 5. Where x to the exponent of 1 is x. Remember, I want to solve for x. So that's our x. But this x is equal to this. Look at what we are having there. It's not simplified. So remember, I talked about having these numbers in simplest form. 32 can be written in the base of 2 to the exponent of 5. But if you do not understand, let's go back to our calculator, guys. We said 32 is equal to, then shift fact 2 to the exponent of 5. So this is the simplest form. So this 32 that we see here, it is the same as 2 to the exponent of 5, which is being raised to the exponent of 4 over 5, which is already given. Guys, I talked about this law. Now and again, an exponent to an exponent, you multiply 5 times 4 over 5 like this. 5 is a whole number, so it's same as over 1. So this was going to cancel. You remain with what? 4. So that was going to cancel here, guys. You remain with what? 2 to the exponent of what? 2 to the exponent of 4. 2 raised to the exponent of 4. 2 multiplies itself 4 times. That's 16. 2 times 2 times 2, 4 times. That's the simplest part that we are having there. So you just have to figure out, guys, how you're given your questions. How are you given the questions? On question number 2.3, they were given this inequality, solve this given inequality, then hence illustrate your solution on the number line if x is a real number. Remember, real numbers can be represented on what? On a number line. So how are we going to solve this? -3, actually it reads 1 minus 2x is greater than -3, but less than or equal to 7. So you just have to bear in mind, guys, how you solve this and be very careful. So I said when solving simultaneous inequalities like this, the simultaneous inequality part, we can get rid of the numbers which are in between here, in between the two inequalities. So let's start with the 1 to the other side and also to the other side. So when you take the 1 this side, you subtract. It was a positive, remember. So it will be a negative this side. So it will be -3 minus 1. Okay, you have removed this -1, remember? So you're going to be left with what? -2x. All right. The 1 to the other side, remember, it will be a minus there. So this is the one that we had here. We took it to the other side. It is a -1. To the other side, it is also a -1. So that is it. -3 minus 1, that's -4. Okay, this one is going to give us what? 7 minus 1, which is 6. So take note, on this part, we have a negative there, -2x. We are supposed to divide by what? -2, both sides. We divide by negative. Here we also divide. Every part we are going to divide by what? By -2, so that we remain with what? With x. But the moment you divide by a negative, you interchange the numbers and the signs. Guys, be careful there. You interchange this one. It will be x. This part here of the signs, these ones, you interchange them because you divided by what? By negative. You interchange these signs. So it will be greater than or equal to. This one will be like this. You interchange this as they are. You just take the, you put it as it is, yeah, this side. As it is, guys, you just interchange the signs. You also interchange the numbers, meaning to say this number will be written this side. -4 divided by -2 is what? It's 2. 6 divided by -2 is what? -3. You're done. Guys, I explained different ways, guys. I don't know which way I'm going to take. Just go through your revisions. But that easiest way, guys, for exam. Because you'll be, remember, guys, exam, you're wrestling also against time. Time management. Time management. After solving, illustrate your solution on a number line. So on our number line, we can see that -3 and 2, in between these two numbers, there is a 0 there. So you can indicate -3 to the left-hand side of 0. This is where we have 2. So at -3, x is greater than or equal to. Once you have this greater than or equal to, you represent with a shaded circle. Greater than or equal to, less than or equal to, shaded circle. Less than or greater than, you represent with what? Unshaded. The circle is not shaded. Then you simply join with what? A line. So these are the x values. They are in between this region, this interval that you're given there. Just like that. So this is it, guys. On the other part, solve for x and y simultaneously, 5 marks. So you've got simultaneous equations. So in this case, you're going to choose, is it elimination? Is it the substitution method? So as for me, I'm just going to work with substitution, guys. Working with the equation 1. I'm going to call this equation 2. On equation 1, I can make x the subject, this one. It's easier for us to have that x as the subject, because we simply have to take these other terms to the other side of the equation. We just have this. We need x. So from equation 1, I'm going to make x the subject. From what? From equation 1. So from equation 1, make x the subject. Make x the subject. So meaning to say, we are going to have it as x is equal to from equation 1. So you take these terms, the 3y, the 5 to the other side. So there will be negative. The 3y, it's a positive. Remember, the moment it jumps the equal sign, it will be negative. The 5, the moment it jumps the equal sign, it will be negative. So remember, we had equation 1, equation 2. So I'm going to name this one equation 3. I made this equation from equation 1. So using the substitution method, okay, I said using what? Substitution method. I made this from equation 1. So I'm going to substitute equation 3 in equation 2. Not where I made the subject, but in the other equation. So substitute equation 3, this one, into equation 1. So, sorry, not equation 1. Sorry, here, equation 2, into equation 2. So in place of x of our equation 2, we're going to put what? This part in place of x. So that's 3x here. So it's going to be 3 into our x. Our x is what? Minus 3y minus 5, like this. Minus 2y. Minus 2y is equal to minus 4. You're done. As long you substitute it back like that, you'll be left with the one variable, which is, in this case, you're left with what? With y. So it means we can solve for what? We can solve for y. How are we going to solve for y? Expansion of brackets, this and that. So the brackets there. Expand your brackets, collect like terms. So that's 3 times negative 3. That was going to be negative 9y. 3 times negative 5, negative 15. We take this part as it is. Negative 2y is equal to negative 4. Collecting of the like terms here, negative 9y, negative 2 was going to give us what? Negative 11. Negative 9, negative 2. That's a negative 11 y like this. Then we've got minus 15, which is remaining, is equal to minus 4. Okay, to get rid of the minus 15, we're going to add 15 both sides, or just transpose it. It will be negative there. So that's it. Negative 11y is equal to what? Minus 4 plus 15. That's positive 11. So you're going to divide by negative 11, this one, both sides, so that we get rid of the negative 11 there and obtain the value of y there. So our y was going to be what? Negative 1, just like that. So we have the y value, which is negative 1. We can substitute this back into any one of these equations. Equation 1, equation 2, or equation 3. But as you can see, it is best that we do substitute into equation 3. If you check properly, because into equation 3, you can see that already x is the subject there. X is equal to what? Minus 3, minus 3y minus 5, like this. So you simply have to substitute the value of y that we calculated, which is what? Minus 1. So that's minus 3 times. Minus 3y means minus 3 times the value of y that you obtained here, which is minus 1. All right, so that's our x. Minus 3 minus 1, that was going to be positive 3. Minus 5, which is 3 minus 5 is what? Minus 2. Just like that. So this is what we're going to have x is -2 and y is -1. You can even write as a point, but there is just solving. X is this, y is this. You're done. These are your simultaneous. So I want you to prove with the elimination method. I want you to use any other method, guys, that as long it is of solving the simultaneous equations, can we apply that and see if you're going to have the same answers? On 2.4, the product of two numbers, x and y is 60. If you multiply two numbers, x, y like this, you get what? A 60. Their sum is 15. Their sum, if you add x plus y like this, the sum is 15. So show that this is going to give us 1/4. How can we show this, guys? Okay, already there's a statement. There's this statement and this statement that we are given. From that statement, can we obtain x, y, and x plus y from here? Okay, let's try. So let's take this part of our left-hand side. 1/x plus 1/y. This is what we are given. We know that addition, we can simply work with the LCM or the LCD of x and y, which is what? xy. Okay, that is our LCM or the LCD. That's xy there. Let's add, remember division, gonna divide this xy divided by what? By x. So you're gonna remain with y times 1, which is y plus xy divided to this y. You're gonna remain with what? X, then x times 1. It's like this, xy over y like this. So you're gonna remain with what? X, then x times 1 is what? X. So this is it, guys. As we can see, xy, which is the sum, this is exactly what we have here. Y plus x, guys, it means x plus y. A plus b is the same as b plus a. Over what? Over xy. This is exactly what we needed. Exactly what we are given here. X plus y is what? It's 15. So let us just substitute, guys. Here we can just substitute. What is representing x plus y is what? It's 15. Over what? xy. What is xy according to our question? Xy is what? 60. What represents xy is what? Is 60. So just substitute. So using your calculator, you can even reduce 15 into 15 is 1. 15 into 60 is what? It's 4. So that's exactly the 1/4 that we are given on that part. That's exactly the 1/4 that we are given. Show that this is going to give us what? 1/4. For 5 marks, guys, this one, it was just, okay, play around. But it can be like that under exam. You just need to play around your questions and be very careful in your simplifications. On question 3, we are given there in triangle ABC, angle C is 90 degrees. This one, there's a right angle, as you can see. So meaning say you can use your trigonometrical ratios. AC 7 units this side. BC this side is 5. AB, everything is already filled, guys, on the diagram. The diagram, like everything is already there. So according to theta, as we can see, all this part is referred according to theta. So let's name our sides according to theta. Remember, you name your sides according to this theta. The side which faces theta, this one, is your opposite. The theta and the 90 degrees, they are adjacent to each other. They are sitting together on this line. They are adjacent to each other. So that's our adjacent. And the one that faces the right angle, this one, the 90 degrees is the longest side. That is our hypotenuse. Knowing this is important because there we need to simplify the cos of theta, this and that. And our ratios. Remember your SOHCAHTOA. All right, remember our SOHCAHTOA concept. So meaning to say 3.11, it is given the cos. So this one is direct, guys. The cos of theta, as we have, is adjacent over what? Adjacent over hypotenuse. So according to our theta, it means the cos of theta is adjacent, which is 5. And what is our hypotenuse? The square root of what? The square root of 74, according to what we are given. it is the square root of 74. You're done. No more simplifications, guys, there that you can do for 1 mark. Just leave it like that. All right? Just leave it like that. Then 3.12, the cot of theta, the cot of theta. So take note, cot is 1/tan, guys. 3.12. So you need the cot of theta. Cot, it's 1/tan. If you're given a cot theta, it's 1/tan theta. But what is tan? Tan, it's opposite over adjacent. This is tan. So 1/this, it means the reciprocal, meaning to say it's adjacent over opposite, the reciprocal. Cot, it's 1/tan. So it becomes what? Adjacent over opposite, the reciprocal. Just like that. So that is your cot of theta, which is our adjacent. It's what? It's 5 over the opposite, which is what? Which is 7. So that was going to be 5/7. Or if you do not understand this, just find tan. Because you understand tan. Tan is what? Tan is opposite over adjacent. Opposite, it's 7. So that's 7 over adjacent is what? It's 5. Then the cot of theta, you know that cot is 1 over what? 1/tan of theta. So it means 1 over the tan, this one. 1/7/5 like this, which is the reciprocal of this one. Or you can even use your calculator, guys. You get what? 5/7. That is what? For the cot of theta. Just like that. So, guys, simplifications can be mathematics, guys. You're not limited. So many ways that you can actually use. Try to work out as many questions as you can. Then cosec squared theta, again for a cosec squared on 3.13. Cosec squared theta. Let's start with a squared. A squared means something like this. Cosec theta squared, like this. When a trig is being squared, sine squared theta means the sine of theta squared. So this is what it means. It means that one's squared. But what is the cosec? If you understand the cosec, guys, the cosec is taken from what? Cosec of theta is taken from 1 over the sine, 1 over sine of theta. Where sine is what? Opposite over hypotenuse. So 1 over sine is the reciprocal. Hypotenuse over what? Opposite. So meaning to say that the cosec of theta, if it is hypotenuse over opposite, we need the hypotenuse over opposite being what? Squared. Remember, sine is opposite over hypotenuse 1. This one is for sine theta. But cosec, reciprocal, 1 over that. Cosec is 1 over that. Just like that. So meaning to say, guys, we can substitute this. What is our hypotenuse? Square root of what? 74. So square root of 74 over the opposite, according to here, opposite is what? It's 7. Everything is being what? Everything is being squared like this. So there you can just use your calculator, guys. Do not waste your time. That's 74 over what? Over 49. So you can just use your calculator. That is the case. 79 over 49. Then another part we are now given to determine hence or otherwise. Hence, it's a continuation from something that you determined. So if it is a continuation, it's best for you to continue from cos because you are used about cos. So they say hence or otherwise. Otherwise, you can find anything that you understand from any information. Determine the size of theta correct to 2 decimal places. So using cos, it's easier for us to determine the value of theta, guys, from that one. Remember to have an angle, right? This is 3.14. To have this angle, theta, this one, if you're given cos theta is equal to 5 over the square root of 74 from the trig of a cos. We need this theta. Theta is our angle, this one. It represents what? It represents the angle. So the angle is equal to arc cos of this one. So the theta, which represents our angle, is what? Arc cos of this part, arc cos of that fraction, 5 over the square root of what? The square root of 74, arc cos. So you can simply use your calculator. Make sure that your calculator is in degrees. There's a D, this one. So that's arc cos, shift cos. That's arc cos, shift cos. 5 over what? The square root of 74. Square root of 74, move aside like this. So that was going to be 54.46 to 2 decimal places. Or you can use your calculator, shift, go to the setup, fix your calculator on number 6, fix it to 2 decimal places. That's 54.46. Just like that. So this is the theta that you were going to have at the end. You're going to have your theta to 2 decimal places like this. So like they said, guys, it's hence or otherwise, meaning to say you can use any ratio that you are used to. You can even use the sign. As long you understand your ratios, guys, these ones, this one, the basic 3, these ones, sine, cos, and tan. Remember, sine is opposite over hypotenuse. So you can find sine opposite 7 over hypotenuse, which is the square root of what? The square root of 74. Then you find your theta, which is the angle. So it will be arc sine this time. Remember, you're dealing with what? Sine. So it will be arc sine 7 over the square root of what? 74. You're still going to get the same answers. You're still going to get the same answers. All right. From this sketch that we are given in this diagram, we are given Q is the point XY. Remember this concept, guys. This will be just at right angles. Q showing us the value of X. That is the values of X, like in this X direction, and the Y vertical from the Y axis concept. So this is our Y, the way that it is given there. Just need to know like the presentation. And this is the distance when the circle is being drawn. So you can just call the radius of the circle from the origin to here. It represents the radius of the circle that is going to be drawn, which is the hypotenuse. So given that is in the what? Second quadrant. And this is given the ratio. It's a ratio that is hidden there. 13 sine theta is equal to 12. It's a ratio which is hidden. Divide by 13, divide by 13 like this. You see it properly. You see it properly. Sine theta is equal to what? 12 over 13. So you can see that they are simply giving us a ratio of sine, which is hidden. It was hidden from that. And remember our ratio of sine. Why am I saying ratio, guys? SOHCAHTOA concept. Remember that your SOHCAHTOA again. Sine is opposite over hypotenuse, meaning to say we are given the opposite over hypotenuse. In the second quadrant, we know that sine is positive. Exactly what we see is positive. Remember from your cast concept. All right, guys, as for us in grade 10, that will be too much. Just know that here it will be positive, guys. A lot there. You learn about it in your grade 11 and grade 12. So let us quickly answer our question. So the question here was 3.21, determine the value of X. So knowing this ratio was important because we know that according to this triangle, according to this angle, this is opposite, the one that it faces, like I said before, guys. So this is your opposite. This is our adjacent, the angle and 90 degrees, they are adjacent to each other. The radius here is our hypotenuse. So knowing this, guys, it was going to help us to find X from the ratio because we are given what? Opposite, which is 12, the opposite here. The Y part there, this part of Y there, our opposite, we have it. It's what? Is 12. Over what? 13, which is the hypotenuse. So you have this one, the hypotenuse here. You have it. It's 13, this part of the hypotenuse. You have it. So you have the opposite, you have this. I mean, according to this part, you have got this side. So it helps this part of knowing this, what was going to help you to fill in. But to find X, guys, what can we do to find X? It's a side. A side. When given two sides, how can you find the third side in a right angle triangle? Pythagoras. We are back to the Pythagoras. So we could have just applied our Pythagoras theorem there. So x squared plus y squared is equal to r squared, the radius of the circle, which is our hypotenuse. So that's x squared is the one that we need the part of x. X squared plus y squared, the part of y, which is part of the y-axis. Remember, that is what? 12. Is equal to what? The radius, which is our hypotenuse there. Hypotenuse squared, which is 18 squared. So that's it. X squared plus 12 squared, that's 144, is equal to 169, 18 squared. So adding, the 144, simply subtract it both sides or take it to the other side of the equation. It is going to be what? A negative there. That's negative 144. So x squared is equal to 169 minus 144, which is 25. So introducing the square root to get rid of the squared there, introducing the square root, you're going to have the value of what? X. Knowing that the square root of any number is what? Plus or minus. So x is plus or minus 5. But which one is the exact value? Because we know our x because of what? The side. This is the y-axis, guys. It tells us to the right, x is what? X is positive. To the left, x is what? X is negative. Our diagram, guys, is to the left. So our x is supposed to be what? A negative value. X, 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 x. To the negative here, to the left side. It's negative. So therefore, x is equal to what? Minus 5. We are supposed to test this value because of the region that we are working with, the side that we are working with from the origin going this side. We are going to the negative region. So our x was going to be negative 5. All right. Understanding this, guys, is very, very important on your diagram because you end up putting a value which is not the one. You put a positive, which is not. All right. Calculate the value of sec theta, 1 mark there. So sec of theta, we talked about this, guys, from our ratios, from our previous type of equation. It's the same thing because the diagram is now having all the information. So that's our 3.22. So the sec of theta is from our ratios. Remember, it's 1 over what? Sec, 1 over cos. Sec, it's like sine. It's 1 over the opposite. So it's 1 over cos. So if you understand that it's 1 over cos, what is cos? Cos is what? Adjacent over hypotenuse. So 1 over that is the reciprocal of this. So it's hypotenuse over what? Hypotenuse over adjacent, the reciprocal, interchange. That's the sec. 1 over cos, it will give us hypotenuse over adjacent. Our hypotenuse is what? Remember, that's 13. And our adjacent is what? Negative 5. Just like that. So that's negative 13 over negative 5, or you can write it as negative 13 over 5, or you can even just leave it like that. All right? That is the case. Guys, just like that. Or you find cos first. You find it as it is. What is the cos? Cos of theta, it's what? Adjacent over hypotenuse. So what is our adjacent? Negative 5 over the hypotenuse, which is 13. So the sec of theta, if it is 1 over cos theta, it means it is 1 over this. 1 over that answer. 1 over minus 5 over what? Over 13 like this. So that's the reciprocal. On your calculator, it will give you what? Negative 13 over 5. Just like that. Still one and the same. One and the same thing. Okay. Then 3.23, calculate the value of 5 tan theta plus 1. 5 tan theta plus 1. So there's just a matter of substituting them. That's a matter of substituting 5 tan of theta plus 1. Let's just substitute, guys. What is the tan? Tan. It represents what? Opposite over adjacent. So that's 5 into what? opposite over adjacent. Whatever that you have there, you're gonna add 1. So that is it. You just have to substitute. What is our opposite here? According to our diagram, opposite is what? Is 12 over the adjacent. This is our adjacent, which is what? Which is -5 plus 1. Guys, you can even use your calculator at this stage. Simplify, use your calculator there. Or you can just even simplify by head, by knowing our numbers. This is same as over 1, so it's going to cancel. We get what? 1 times -12 here, which is -12 plus 1, which will give us what? -11. This is from our understanding of what? Understanding of numbers. From your understanding of what? Of numbers. Or you can simply use your calculator if the understanding of numbers is somewhere. Therefore, use your what? Use your calculator. You're going to have the same thing. So questions can be of this nature. You have to be careful. How questions are given. How are we given our questions? It is very, very important to know the simplification thereafter on your question. So looking into question number 4, we are now given to solve for x. So in this question, where x is taken from 0 to 90 degrees, in each of the following equations, give your answer correct to 2 decimal places. There's an instruction that you're given to follow. All right, so let us quickly check this, guys. Under our trigonometry, we do understand that if you're given this in between 0 to 90 degrees, as of our level, you shall be working with the 0 to 90 degrees, nothing much, guys. So that case, do not worry. All angles that you'll be working with, they'll be positive. So just take this one as it is, guys. All right. So that's 5.75 like this. So this part here, it represents the angle. Remember, for us to have the angle, it will be arctan. If you are given sine, it will be arcsine, whatever that you have. So in this case, this angle here, the angle that we need, the part of 3x, will be equal to what? Arctan. You take the tan to the other side, so it will be written as what? As arctan like this. So that's arctan 5.75 like this. So that's 3x is equal to arctan. Remember, we are told to use 2 decimal places in our simplification. So as I'm using my calculator, I'm just gonna write, or it's already fixed to 2 decimal places. Remember, we fixed it back to 2 decimal places. So that will be shift tan 5.75 like this. So that is what you're going to obtain, 80.13. So that's 80.13 degrees. The angle, remember, the moment you find arctan, you are finding the angle. This part, it represents what? The angle. So here, you have it as degrees. It's now an angle that you're having. So to have your x, simply divide by what? By 3. It's an equation. So the same way that you solve your equations. So that's 80.13. Then the answer there divided by what? By 3, which was going to be 26.71 to 2 decimal places. So that's 26.71 degrees, all right? Just like that. So guys, this is the simplest part of your trigonometry. Just try to do as many questions. So if you're given the cosec of x minus 35 degrees like this is equal to what? 7.814 like this. So remember that cosec means 1 over what? 1 over sine. Cosec is 1 over sine. So this will be 1 over the sine. So it's the sine of what? Everything as it is. The sine of x minus 35 degrees, which is equal to 7.814 like this. So it is easier to work with the sine, guys, because of our calculator. We have the sine, the cos, the tan. So those cosec, yes, you have to extend your calculators, but using the sine is easier that way. That's over 1. You can cross multiply so that we make the sine the subject. So cross multiply, it was going to be 7,814, which multiplies this sine here. So it's times the sine of x minus 35 degrees. So this is equal to 1 times 1, which is equal to 1. So we need the sine, just like here, we had a tan, a single trigonometry of a sine. So we need this single part of a sine here. So what is affecting is the 7,81, this one that is multiplying. So divide by it, 7,814. Also divide this side, 7,814. It was going to cancel. So that's it. You have a single trig, just like a tan, but you're working with a sine which you have on your calculator that you can simplify. So it means the sine of x minus 35 degrees is equal to this. You can have it as a decimal. Yes, you can leave it as a fraction as it is, 7,814 over this 7,814. Remember, I said this represents what? The angle. That is your angle, this part here, the x minus 35. So it means for us to remain with that angle of x minus 35 degrees, we must have arc sine. On the other side, we write this sign as what? Arc sine. So it is going to be what? Arc sine of 1 over 7,814, like this, arc sine. So that's it. Once you have it there, guys, it will be an angle. The moment you write this arc sine, you have an angle there. So it means x minus 35 degrees is equal to what? Let's find this on our calculator. Arc sine, that's shift sine, 1 over this decimal as it is 7,814, just like that. So it was going to give us 7,35. Remember, we have already fixed our calculator to 2 decimal places. So that's 7,35 degrees. So to find our x, simply transpose negative 35 to the other side of the equal sign. It will give us what? A positive 35 there. So that's x is equal to, you add these two, it was going to be 42,35 degrees, just like that. So this is how we could have solved this trigonometric equation. So trigonometry, you have equations there are also, just like algebraic equations. So the same part on question 4.12, 4.13, we are given that's the cos of 2x plus 10. Cos of 2x plus 10 degrees, like this, everything over what? Over 3 is equal to 0,159, just like that. So what we need is to have a single trig, this one, so that we can find its arc cos. So what is affecting the 3 here? Remove that one. Remember, this is same as over 1, so you can what? Cross multiply, so that we get rid of the 3 there. So that's 1 times the cos, which is the cos of 2x plus 10 degrees, which is equal to 3 times this one. You multiply 3 times. You multiply those two. 3 times this. So that's 3 times 0,159, which was going to be 0,477. Okay, so take note. Do not fix your calculator when multiplying this. You fix your calculator when you find the arc cos, because it will affect your answers. Remember, it is the final answer which is needed to 2 decimal places. When you're finding the arc cos, that's when you find 2 decimal places. So make sure there, guys, you put back your calculator to the normal mode. Just like the previous case, this is our angle 2x plus 10. So how are we going to remain with this 2x plus 10? We have to get rid of what? The cos. The cos here that we have. How do we get rid? We write it here as what? Arc cos. So 2x plus 10 degrees is equal to what? The arc cos of 0,477. So that's the case. Just like that. So meaning to say we're going to have 2x plus 10 degrees is equal to arc cos of this, which is going to give us, just we need our calculator there, shift cos 0.477. So to 2 decimal places, that's 61.51. 61.51 degrees. We want to solve for x. What about the plus 10? Remove it. So you can subtract the 10, also subtract the 10 this side. So this will cancel. So meaning to say 2x is equal to what? We are subtracting. So it is going to give us 51.51 degrees. Divide by what? By 2. Having your answers to what? To 2 decimal places. So 51.51 divided by 2 on our calculator. That's 51.51, then divide by 2. It was going to give us 25.76. So that's 25.76 to 2 decimal places. Just like that. Okay. Now let's consider another part, which is 4.2. On 4.2, you're given if A is 70 degrees, B is 40 degrees. Use your calculator to evaluate the following correct to 1 decimal place. They're saying use your calculator. So it's just a matter of substituting, guys. This type of equation is the easiest one. Just substitute tan A plus B. What is representing A? What is representing B? Our A is what? 70. Our B is what? 40. So this is tan of 70 plus 40 like this. So you can even add, use your calculators, or you can even add, guys, by head. 70 plus 40 is what? 110. Then use your calculator, tan 110 to how many decimal places as we are given? To 1 decimal place. Follow the instruction. So to 1 decimal place, this time we must fix our calculator. All right, that's shift, go to the setup, you fix on number 6, you press 1 to 1 decimal place. So it's now to 1 decimal place. So tan 110 is equal to what? Minus 2.7 to 1 decimal place. We've already fixed our calculator. So that's minus 2.7. There is no degree there. There's nothing, just a number as it is. Okay, just like that. So the same situation, we're going to use it to simplify 4.22, which is the sine squared. Remember, I talked about this, guys, when you're given a squared like that. Sine squared of A means what? It means the sine of A like this is squared. The sine of the whole of it, not this, not sine A squared like this. This is wrong. The sine of A, the whole of the sine. The A is what? 70. So it is the sine of 70 degrees, everything squared. Meaning to say we can find the sine of 70 on its own, or we can use our calculator to find everything. Open a bracket, sine 7. Take note, when you open this bracket here, take note. This bracket is the one here. This bracket is this one. This bracket here. So once you put the sign, the calculator opens here its own bracket that you're supposed to close, and you close the first one that you opened here, you must close it, then raise to the exponent of 2. So be careful on that part, right? So we are going to have what? 70 degrees. We close this bracket, the one that was opened by the calculator. Then we close the one that we opened as this one. This is the one that we put as. So we must close it at the end. Then we square. Okay? So we are going to close this. Then we square. So that is the case there. All right? So squaring this, what was going to give us what? 0.9 to 1 decimal place. Remember, we're given the instruction to 1 decimal place. Just like that. All right? Another part, we are given the cube root of this part, the cube root of a sec. All right, that's 4.23. Remember that sec this sec, it's 1 over cos. So this one is the same here. 3b over 2, it's one thing, this one. It's one part. It's one and the same, this one. So, okay, let's simplify it first so that we do not have confusion. So it's 2 sec of what? 3 times b. 3b means 3 times b. b is what? It's 40 degrees. 3 times what? 3 times 40 over what? Over 2, like this, so that you can understand what is given there. So it will give us the cube root of what? 2 sec. Remember, there's a sec there. 3 times this. On your calculator, guys, you can simplify this. It was going to be what? 60 degrees. This part was going to give us 60 degrees, this part. So it's 2 sec 60 degrees. 2 sec 60 degrees. We can't simplify the sec on our calculator. So we have to introduce what? What we can simplify, which is what represents sec. Sec, it's what? 1 over cos. 1 over cos theta. So we are going to have 2 times sec 60. This one is the product. 2 times. So it's 2 times. Sec, it's what? 1 over cos. 1 over cos theta, where your theta is what? 60 degrees. So it's 2 times 1 over cos. With this, you can use your calculator. Yes, you can simplify to say 2 over 1. Then is going to be the cube root of 2 times 1, which is 2 over 1 times cos 60, which is cos 60 degrees. Yes, you can write it like that, but you can even simplify, guys. The cube root here on our calculator, take note the cube root. It's here where the square root is. The cube root is there. If you want to use direct the cube root on your calculator. So it's shift. So it's going to be shift here. The cube root. Yeah, shift. Sorry. So it's going to be shift. You press this. Must give us a 3. So it's 2 over what? Cos 60. 2 over cos 60. Cos 60 degrees. So that's it. 1,6. Or we are simply saying the cube root of 2 times 1 over cos 60, like this. So it was still going to give us what? 1,6, just like that, to 1 decimal place. So this is how these questions are simply given, guys. Try to do as many questions. Then let's check out 4.3 without using a calculator. Simplify this. So guys, whether they said without using a calculator or not, guys, you can even use a calculator. These are just special angles. These are just special angles. I talked about these, guys. So you can simply use your special angles. Remember, your special angles. Do not forget your triangles if you are to use this. Remember for, okay, let's put it this way. I'm going to put 60 degrees here, 30 degrees here. Remember, it's 1, 2, square root of 3. Guys, this is just a revision. You're supposed to know these ones. This is for 45 degrees. We have got 45 there, 45, 45 here. So for 45, it's 1, 1 square root of 2. This is the triangle for 45 degrees. So we are given cot squared. Remember, I talked about a squared. Cot squared. Cot squared. It means cot 60 degrees squared, like that. Cot. And our SOHCAHTOA can help us. SOHCAHTOA. Cot. What do we understand by cot? The cot of theta, it's what? The cot of theta, it's 1 over tan. Cot of theta, it's 1 over the tan of theta. So if it is 1 over tan, remember tan is opposite over adjacent. And we are saying 1 over tan, so it's the reciprocal, the opposite of that one. So it's going to be what? Adjacent over opposite. So cot, it's adjacent over opposite. Knowing this, guys, is important. Very, very important. Because on this part, you are simply going to substitute to say cot 60. According to our triangle, this is the triangle where we have got 60 degrees. According to 60, remember we need adjacent, opposite. Forget about this 30. Focus on 60 degrees. According to 60 degrees, according to 60, this one. This is our adjacent. This is our opposite. That is the case. According to 60. This is the opposite. So we need what? Adjacent over opposite. Adjacent is 1. Opposite is what? Square root of 3. So that's 1 over the square root of 3. Then you square it. Cot squared. Cot 60 squared. Or you're going to find tan, because you know that that is the opposite. 1 over reciprocal, 1 over tan. You're going to find tan what? Tan 60. What is the ratio of tan? Opposite over what? Adjacent. Opposite over adjacent, which is the square root of 3. So cot, it becomes 1 over tan. So it will be 1 over tan. The answer that you got, 1 over what? Square root of 3. Just like that. All right. Let's move on to another one. Tan 45. So tan 45, guys, is direct. This is a product times there. That's a product. Tan 45 is either anyone that you want. If you're using this one, this is our opposite. This is our adjacent. Remember, tan is opposite over what? Adjacent. So it's 1 over 1, which is what? 1. So tan 45 is 1 times sine 30. According to this triangle, this is where we have 30 degrees. And according to 30 degrees, according to this angle, this is the opposite. It faces this side. This is the opposite. This is the adjacent. This is the hypotenuse. According to that, I'm saying according to that, please be careful. According to 60, this is opposite. But according to 30, this is what? Adjacent. So you name according to the angle. You name these sides according to the what? To the angle. So sine 30. Sine opposite over what? Hypotenuse. So of 30, this is our opposite, which is 1 over what? Hypotenuse. Hypotenuse is 2. So that's 1 over 2. Just like that. Everything over what? Cos 60. Cos 60 degrees. We have to name again our triangle according to what? Our angles. Cos 60. Adjacent over what? Hypotenuse. Cos. This is our adjacent, hypotenuse, 1 over 2. So like I said, guys, you can even use your calculator, guys. There's nothing special about these special angles, guys. Go back to the normal mode. All right. So you're going to go back to the shift, go up to the setup there. Go back to the normal mode on number what? 8. Number 2. You were given, in this case, the tan of what? The cot of 60, which we said is going to be taken from 1 over tan. So simplify. Tan, what is tan of 60 degrees? There's nothing special there. Square root of 3. So you know it will be 1 over square root of 3. Simplify tan 45, guys. You see, you get same answer as 1. Sine what? Sine 30. Who is going to know that you have used these triangles or not? Because knowing this by head, knowing this from these triangles, knowing this from calculators is the same. That's why you call them the special angles. Otherwise, nothing special there. You can even use your calculator. As long as you are wise enough to show properly your stages, they won't even see that you haven't used a calculator. Yes, they said without. You can do that with a calculator and no one can see that you haven't. You used a calculator. All right, anyways, guys, let's simplify. These ones is direct. The denominator to the numerator can cancel. Then they've got 1 over the square root of 3 squared. You can even use your calculator there. Or you can simplify like this. Remember your exponents, 1 squared. So that's 1 over the square root of 3 squared. Your seds, square root of 3 times the square root of 3 is going to give us what? 3. Square root of a times square root of a is a. Or just use your calculator, guys. That will be what? 1 over 3. So that's 1 over 3 times what? Times 1. Remember, this one cancelled is just a 1 there. So what is 1 over 3 times 1? 1 over 3 times 1 is simply what? 1 over 3. So this is how these questions, guys, might be given. Just continue to revise as much as we can. Try to prepare yourselves for the exams which are ahead of time. Make sure that each topic, as it is in your ATP, as it is for term 1, you have revised every topic, because that is how it is going to be for your March test. The topics that you covered, those are the topics that you're going to have in this test. So it will depend, guys, with the provinces. Like we have this one is for KZN, so we shall see if we're gonna have other question papers from different provinces, so that we have them, so that we can work them together, so that you can see different provinces, how they ask these questions. Try to figure out. You see that it's similar, one and the same thing. Guys, it's just one and the same. Just do as many questions as you can. So maths, it's all about practice. Do as many questions as you can. You as an individual, do many questions. That is all about maths. It's supposed to be you and the fingertips. So let's try to work out much questions, guys.